Alright, this is section 5-9 on measures of central tendency, which is three things: mean, median, and mode. So we're going to start with a couple examples. Example number 1. So first we have the mean. Mean is the sum of the numbers divided by the number of numbers. And so in example 1, this would be 1A. 1A, you have the sum of the heights. You have a little table there. So if you add all those numbers together, which I'm not going to do, you get 732. And we're going to divide that by how many numbers there are. So if you count those numbers, there are 12. And so to find the mean, you're going to take bottom into top, and you're going to figure that out. So this goes 12 into 7, 0 times, 12 into 73, 6 times. 12 into 10. Yeah, actually there's a little bit of a mistake here. That should actually be 732. Not sure why I wrote that down. So that means you drop down a 2, and that's 12 into 12, which goes once. So the mean for this is 61. Median is about putting the numbers all in order from least to greatest, or greatest to least, it doesn't matter. And then you are crossing off one on each side. 1, 1, 1, 1, 1. And then there's 2 in the middle. So these 2 were the ones we crossed off last. Whenever you cross off 2 in the middle, you add them together and divide by 2. So if you add those together, you get 121 divided by 2 is 60.5. And if you notice, that number is right in the middle of 60 and 61. 60.5 is the halfway point between those two numbers, and that's basically all you're trying to do. And the last thing that we got here is mode. And mode is just finding, and it's really easy when you have them all listed in order. Mode is most. So that the one that occurs the most is this 59 that I just boxed off. And you can tell because there are 3 in a row, and none of the other numbers as you go through the list have 3. But if there were 2 numbers, if there was 3 59s and 3, say, 63s, then you would have 2 modes. You'd have both of them. So any number that gets repeated the same amount of times as another one, then they both would happen. So that's example number 1. Let's look at example B. Alright, in this one you are counting up. If you look at the chart that you have there, it's called a line plot. Every X that you see on there represents a different number. So on this one, if I'm doing the mean first, I'm going to add up all the numbers. So what I got is a 2 plus, and then there's 4 3s. So I could add them all together like this, or I could just take 3 times 4. And then if you count up the number of 4s, there's 6 of them. So add 6 4s, or just times 6 times 4 and add. If you look at the 5s, there are 5 of them. I'm going to keep adding here. And if you look at the 6s, there's 2 6s. Look at the 7s, there are 4 7s. Look at the 8s, there are 3 8s. And once again, you could just take 8 times 3. Plus, there are 4 9s, so you could take 9 times 4. Or you could just add all 9 of the, or 4 of those 9s. Plus a 10. And plus an 11. So those are all the numbers. And what, you could make this a little bit easier. 3 times 4, 4 times 6, plus 5 times 5, plus 6 times 2, plus 4 times 7, plus 3 times 8, plus 9 times 4, plus 10 plus 11 plus the 2 in front. And then you're going to divide that by how many numbers there are. So what you could do is you count up the number of x's, and there are 31 x's. So we're going to divide by 31. So to keep going here, we've got, if you add up all those numbers together, you get 184, and then we're going to divide it by 31, and if you do that and you round, you get about 5.9 if we're rounding to the nearest tenth. So that's example 1B. We've also got the median to do. So since they're already in order up front, I'm just going to do that. 2 and 11, 3 and 10, 3 and 9, 3 and 9, 3 and 9, 4 and 9, 4 and 8, 4 and 8, 4 and 8, 4 and 7, 4 and 7, 5 and 7, 5 and 7, 5 and 6, 5 and 6, which means there's a 5 in the middle. So the median is 5. And then the mode, the one that happens the most, if you look at it, really easy to tell here, there are 6 4s. So 4 is the number that repeats the most. That's the mode. And that's example 1B. In example 2, we have a table showing the daytime high temperatures for a week. Which measure of central tendency best represents the data? Then find the measure of central tendency. Well, what you do here, it says in the book, it says, since the set of data has no extreme values or numbers that are identical, the mean would best represent the data. So as you look at the numbers, we've got 84, actually we'll just add them together, plus 83, plus 89, plus 90, plus 91, plus 85, plus 80. There's no extreme values, which means there's no numbers that are really different than the others. You know, you go from 80 to 91, they're pretty much all in the 80s, and then 90, 91. So there's no extreme values, so that means your mode would not be a great measure of central tendency, and median would not be. So if you don't have extreme values, then mean is your best one. So we're going to take all those numbers, add them together, and divide by 7. When you add all those up, which you have to do, you get 602, divide it by 7, and when you do that, you get 86 as an average. That is the mean, and the mean is the best measure of central tendency. That's example 2. Let's move on to example 3. And this is pretty similar to the last question. You've got a table showing number of calories per serving of each vegetable. Which measure of central tendency best represents the data? Then find that measure. As you look at all these numbers, you're going to notice that there is a number that is really big compared to the rest, and it's 66. It is much larger than the rest, so that is called an extreme value. And anytime you have an extreme value, it messes up your average. So an average is mean. So anytime you have a number like that, it messes up your mean. It doesn't give you a great measure of central tendency. So when we have an extreme value, it messes up your mean, and that means that your median becomes the best measure of central tendency, because you're just finding the middle number. So what happens here is, if we put all these in order, 14, 17, 17, 17, 20, 25, 28, 30, and 66. So let's find the median. Cross off high and low, low and high, low and high, low and high, low and high. So if you add 17 and 17 together and divide by 2, you get 17. It's the average of 17 and 17. So that is your answer, and that is median is the best measure of central tendency. Let's go into example 4. So on this one, we are, it says the average wait times for 10 different rides at an amusement park are, and then they have 10 numbers listed. Which measure of data would the park advertise to show the wait times for its rides are short? In other words, we want to find the one that has the smallest number. So if we find the mean, median, mode of each of these, mean on this one without doing all the work would be adding up all those numbers, which is 334, and dividing by the number of those rides. There's 10 rides. So if you divide that, you get 33.4 for mean. Median, if we put all of those in order, we have 11, 17, 17, 21, 22, 25, 44, 52, 60, 65. Put them in order, cross off. Since there's 10, that means we'll have 2 in the middle, which there is. What is right in between 22 and 25? Well, if you know that answer, you won't have to add those and divide by 2. Right in the middle is 23.5. That's directly halfway between each. So that's a median. And now the mode becomes really easy to see. The mode, here's one that's repeated twice. I don't see any other number that's repeated twice, so the mode is 17. So, which one would they want to use to advertise the smallest one? So, the advertisement of the shortest wait time rides. Mode is 17. That's the smallest. That's the one they'd want to use. Good luck.